There might be a cut in this video because I had gotten disturbed at this point, so I'll continue. So we're going to do point on a calculator. Going to do negative 0.927 squared is equal to, oh, I made a mistake. When you do a negative, you have to put it in parentheses. So we're doing parentheses negative 0.927 squared. Another sign that I made an error there was that I know if I square a number, I should get a positive, and it gave me a negative. So we should get 0.859 oh, not point, the little space that they have in the numbers on this calculator app I have made me think of putting a decimal there, which is incorrect, 92, plus cosine square theta is equal to 1. We're going to get cosine square theta by itself by just subtracting. So I'm just going to do it on the calculator in this case. I'm going to do 1 minus 0.8, whoops, not 0, 859,329. And we'll get that cosine square theta is equal to 0.140671. And again, for space, I'm going to move my way up this way. So I'm going to take the square root of both sides to figure out what cosine of theta is. So I'm going to get that cosine theta is equal to approximately, take the square root of 0.140671 is 0.375. I'm going to go with this because, again, the y value had this many decimals. That's not necessarily the way you should round. You should round wherever the problem tells you to do so, but because I'm making a lot of these problems myself, one of the few things I keep forgetting to do is specify what to round to. Anyways, if we want to find out what theta is, we just have to use cosine inverse of 0.375. So cosine inverse of 0.375 is 67.98 degrees. So probably something like 68 degrees is what I originally set up this problem to be. I know I rounded my coordinates so far. Anyways, so that's how you can find the missing part of a side and the angle given either the x or the y value. Pretty much what you're being given is in the unit circle, you're being given the, you're either being given the sine or cosine, and then you're finding the other one based on that, based on the Pythagorean identity. Actually, we're actually not finished with this question, because what we found is the measure of this angle here. This angle is 67.98 degrees, but the angle theta we were given originally is actually 180 degrees bigger. So we should really take that 67.98 and add 180 to that. So I'm going to take that answer, 67.98, and add 180 degrees. And that is the measure. This is a 247.98 degree angle. So that's what the angle in this, around this unit circle was drawn in standard position. All right, because the Pythagorean identity assumes that you're using a right triangle. All right, so let's take a look at how this would apply to this problem here. Number one, the terminal side of an angle, the terminal side of theta, an angle in standard position, so that means we have a circle. An angle is drawn in standard position. Terminates, is at the point x negative radical 5 over 3, so that's over here. Okay, in quadrant 4. So there's an angle here that wraps around. So this is the angle out here, theta. Alrighty. And we know that this coordinate is x negative radical 5 over 3. All right, so in order to answer this question, we're going to make our triangle here. What we're going to be finding is the measure of this angle here, which will help us find the rest of the angle. So we're going to use the Pythagorean identity to figure out what that is. So we have the y value, so that's sine. So sine square theta plus cosine square theta equals 1. We know what our sine is, so we're going to make that negative radical 5 over 3 squared plus cosine square theta equals 1. We're going to do the same thing we did a minute ago and figure out what cosine is. So if we square that, negative radical 5 times negative radical 5 is just 5 divided by 9, so 5/9 plus cosine square theta equals 1. If we subtract 5/9 to the other side, we'll get 4/9. So cosine square theta is equal to 4/9. And if we take the square root of both sides, we get cosine theta is equal to 4 over 9. All right, so that means that x is 4/9. So this value here is 4/9. Now, because we're in quadrant 4, it's positive. If it was in quadrant 3, it would have been negative. Now we can use this to find out what the measure of the angle is. So we're going to do cosine inverse. So theta is equal to cosine inverse of 4/9. We also could have done this with sine, so we could have just done a sine inverse of the angle we already had. So you could do second cosine of 4/9 and get approximately 64 degrees. All right. Now it didn't ask us for that, but if we wanted to figure out what this, so this is 64 degrees, 64. If we wanted to figure out what the angle theta was, which is not what we were asked for, we can very easily do that. It's just a full circle, which is 360. Minus 64 would be 296 degrees. So the original angle in standard position was 296. Again, we weren't asked for that. We're being asked for the secant of theta. All right, so secant in this quadrant, we remember we have all students take calculus, and that means cosine is positive in this quadrant, and secant is the reciprocal of that. So our answer should be positive in this quadrant. Remember the radius is 1 because it's the unit circle, and the secant of theta is the reciprocal of cosine. So cosine theta is adjacent over hypotenuse. So secant theta is hypotenuse over adjacent. So from our angle here, adjacent is the x value, which is cosine, or 4/9. So it's really, this is 4/9. So it's, cosine would be 4/9 over 1, so we have 1 over 4/9. So this is 1 over 4/9. Now I'm going to call 1 over 1. So secant theta is going to equal to, I'm going to use keep change flip. I'm going to write 1 over 1 times 9 over 4 and get that secant theta is equal to 9/4. Because 1 times 9 is 9, and 1 times 4 is 4. You can try and do example 2 on your own. I'm just going to show you one more example on the back of the worksheet. All right, and then there's a couple of Regents problems for you to do as well. Show work as much as possible. Now, this particular question says, number 5, that there's an angle drawn in standard position that passes through the point 4, 6. Now, because it's 4, 6, it's obviously not on the unit circle, because that would make that would make this circle way too big. All right, so the question says, what is, let's read this carefully. Angle theta is in standard position, so it's here. Standard position means that we're starting at 0, 0. All right, whoops. And the terminal side of theta is at 4, 6, which means this side of the triangle is 4 long and this side is 6 long. The question says, what is the exact value of cotangent of theta? So cotangent is just adjacent over opposite, because tan is opposite over adjacent. Now, conveniently, based on this particular angle, we have our opposite and we have our adjacent. So we don't need to figure out what the hypotenuse is, but if we were asked for secant or sine or cosine, we'd have to do that. So if you look at the next question, you're asked for cosecant, so you'd actually need to figure out what the third side is using the Pythagorean theorem. So we're going to do cotangent, which is just this upside down. So the cotangent of theta is equal to the adjacent, which was 4, divided by the opposite, which is 6. We should simplify that to cotangent of theta is equal to 2/3. And that's pretty much that. If you have any questions, make sure you ask on PeoplePath or on Google Classroom. Have a nice day, everyone.